Hi, my name's Logan Morgan.
And I'm Ben Wacker.
Three topics that we thought were difficult for this semester were verifying identities, vectors, and conic sections.
So we have 6 tips that you could use for verifying identities, and we're just going to go through them. Step number 1 is to convert to sine and cosine, and this is something that we emphasize in class. That's just saying if you have like tangent or cotangent, cosecant, and secant, to convert those all to sine and cosine. Step number 2 is a plus b to c, and that means if you have 2 terms on the left and 1 term on the right, to solve the side that has 2 terms on it, because that's the harder side. And step number 3 is the exact same. So if you have it's c to a plus b, so if you have 1 term on the left and 2 terms on the right, to solve the right side of the equation to equal the left side. So that's just saying verify the most difficult side first. Step number 4 is changing division to multiplication. That's just a recommendation. It makes it easier. You don't have to, but it's just recommended. Step number 5 is to multiply by the conjugate. So that's just using the reciprocal identities. So that would be saying, for example, like sine of x equals 1 over cosecant of x. So that would be like that. And then step number 6 is to factor. So if you have a sine squared x on a sine and on a side, and you want to get it to sine, you can start by factoring out a sine.
In order to verify identities, you're going to need to know your identities. There's a Pythagorean, the quotient, and the reciprocal identities. The earlier you remember these, the easier your life's going to be. So for the Pythagorean identities, you have cosine squared plus sine squared equals 1. You have 1 plus tan squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. For the quotient identities, you have tan x equals sine x over cosine x, and then you have cotangent x equals cosine x over sine x. For the reciprocal identities, you have sine x equals 1 over cosecant x, and cosine x equals 1 over secant x. Then you have tan of x equals 1 over cotangent of x, and then cosecant x equals 1 over sine x, as well as secant x equals 1 over cosine x, and cotangent of x equals 1 over tan of x.
Okay, so we're going to start off with an example, and we're just going to start easy just to explain the concepts that we talked about, or the tips. So we have sine x times secant x equals tan x. And the first thing that we're going to do is we're going to convert the secant x into sine, or in this case cosine, because that's what it's associated with. So it's going to look like, you're going to keep the sine x, and it's going to look like this. We're going to use the reciprocal identity. So we're going to use this one right here. And it's going to be 1 over cosine of x times sine x. And then this one will stay the same, this side. And the reason I'm choosing to do the left side versus the right side is because of the tips number 2 and 3 that we talked about, how a plus b to c, or c to a plus b, we're solving the side that looks harder. And to me, this side looks harder. So from there, we're just going to combine the tops and bottoms, because technically this is over 1. And so we're just going to use a common multiplication rule, and we're going to get sine of x over cosine of x equals tan of x. And from here we can see that sine over cosine is one of our identities. It's a quotient identity, and that equals tangent of x. So then tan x equals tan x.
For our next example, we're going to use cotangent squared of x over cosecant of x equals cosine of x over cotangent of x. We're going to start off by splitting this into 2 separate fractions, the left-hand side, and we'll get cotangent squared of x over 1 multiplied by 1 over cosecant of x equals that. Then you're going to use the quotient identity to get cosine squared of x over sine squared of x multiplied by sine of x over 1 equals that. And this right here is a reciprocal identity. The next step is to cross multiply, and the signs will cancel out. So you'll get rid of this sine squared and that sine, and you'll get cosine squared of x over sine of x. Then you'll split this cosine into two separate terms. You'll get cosine of x times cosine of x all over sine of x. Then you're going to split this term into cosine of x over sine times cosine of x. The next step is to use a quotient identity, and cosine over sine equals cotangent of x, and then cosine over 1 equals cosine of x. And as you can see, that's what we started with up here. So your final answer is cosine of x times cotangent of x equals cosine of x times cotangent of x.
Okay, so we have another example for you guys, and this one's a little bit more difficult, depending on how you look at it. We think it's more difficult. So we're going to start off by having tan of x times sine of x plus cosine of x equals secant of x. So our plan here is, as you can see, we have two terms separated by an addition sign on the left side and then one term on the right side. So our plan here is to work with the left side and keep the right side the way it is. So we're just going to keep that, and we're going to work with this one right here. So first off, convert everything to sine and cosine. That's always step number one, and that's highly recommended. That's what's going to make, it's almost required if you want to look at it like that. That's what's going to help you get to this secant in this example. So we're going to do, this tangent is equal, we're going to use a quotient property, and that's equal to sine of x over cosine of x. And then this is just, we're going to keep this the same, so that's just going to be sine x, and that's technically over 1. And this one we're going to keep the same as well because it's cosine, so it's already converted for us. And that's cosine of x, and that's also over 1. So next we're going to find a common denominator. And so in this case our common denominator is going to be cosine of x. And so we're going to start off by combining this sine x with this sine and cosine. So we're just going to go ahead and do that. We're going to multiply across, and it's going to look like sine squared x over cosine of x plus cosine of x over 1. And so here we're going to combine them with a common denominator, and it's going to look like sine squared of x plus cosine squared of x all over cosine of x. So here we just multiplied by cosine of x over cosine of x in order to get common denominators, and this right here turns into cosine squared of x, which is how we got this term right here. Next, we're just going to convert the top here, and as you can see, this is sine squared x plus cosine squared x, and that's a Pythagorean identity. That's the first one right here, and so that's just all equal to 1. So that's just going to turn into 1, and then we're going to keep our denominator. So it's going to be cosine of x. And as if we take a look at our reciprocal identity, 1 over cosine of x is equal to secant over x. Which is what we were trying to get to. So that's just going to be equal to secant over x.
All right, so for our fourth and final example, we're going to be using cosecant squared of x multiplied by tan squared of x minus 1 equals tan squared of x. The first step is going to be to convert this using the reciprocal identity into 1 over sine squared of x multiplied by sine squared of x over cosine squared of x. And you use the quotient identity to convert tan squared of x equals sine squared of x over cosine squared of x, and then you pull the 1 down. The next step will be to cross multiply. So these will cancel out, and it'll get 1 over cosine squared of x minus 1 equals tan squared of x. 1 over cosine squared of x equals secant squared of x, and then minus 1. And then you're going to use a Pythagorean identity. And if you rewrite the Pythagorean identity, so it's 1 plus tan squared x equals secant squared of x. If you subtract 1 from both sides, you'll get tan squared x equals secant squared of x minus 1, which is what we have here. So your final solution is tan squared of x equals tan squared of x.
So I'm going to go over the tips again to make sure that you understand them. If you can't see them, that's okay. I'm going to state them. So the first tip that we talked about that we used today was converting to sine and cosines. So every time you have tangent or cosecant or secant or whatever it may be, if it's not sine or cosine, make sure you convert it to sine or cosine. Number 2, a plus b to c. And then number 3, c to a plus b. All that means is just make sure you solve the more difficult side first, because that will make it easier on yourself when it comes to verifying it. Number 4, division to multiplication. That just means, that's more of a tip. If you want to make it easier for yourself, you can switch. You can just make sure you change division to multiplication by using the reciprocal identities. Number 5, multiply by the conjugate. So that's just also another way of using the reciprocal identities. That'll make it easier on yourself. And then finally, number 6, factor. And that'll come in handy if you have like a sine squared of x or a cosine squared of x, if you have any kind of squared that you need to factor out where there's more than one term on that side.
Alright, so I'm just going to run through the identities one more time. We have the Pythagorean, the quotient, and the reciprocal identities. Cosine squared plus sine squared equals 1. 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. The quotient identities are tan of x equals sine of x over cosine of x. Cotangent of x equals cosine over sine of x. And then the 6 reciprocal identities. Sine of x equals 1 over cosecant of x. Cosine of x equals 1 over secant x. Tan of x equals 1 over cotangent of x. Cosecant of x equals 1 over sine of x. Secant of x equals 1 over cosine. And cotangent equals 1 over tan. The best way you can memorize these is by creating flashcards. And the best way that you can get good at verifying identities is just to practice them.
So my name's Ben.
And my name's Logan.
Thanks for watching.